Bismillahirrahmanirrahim. Here is course oxidation reduction with respect to organic synthesis. We will discuss today Collin oxidation. This is our today's topic, that is Collin oxidation. This is a special type of oxidation of secondary alcohol to ketones. So this was designed by Collin. We will discuss its reaction. Collin oxidation. It is a mild oxidation process in which secondary alcohol and primary alcohol, they are converted into ketones and aldehyde. In this case, you can see the reaction over here on your screen, that primary alcohol in these conditions, it is oxidized to aldehyde, and yes, no more further oxidation is possible. So that is why it is a mild oxidizing agent. Here, the conditions are chromium oxide in the presence of pyridine, so in basic media. So this type of oxidation is specialized for those organic compounds in which there are acid sensitive group. So for that case, we selected this Collin oxidation for oxidizing some functional group. Uh, Acid sensitive group, uh, for example, in Jones oxidation, we use HCl rather than pyridine. So there is possibility of any other functional group which is acid sensitive, that maybe it is converted to some other functional group, or it is degraded or whatever. But in this case, if the use of pyridine, the use of base or basic media make it useful. And that is why the acid sensitive group can be saved by using these type of oxidation. So the mechanism, we will discuss its mechanism by taking this example. Here is our nitrobenzaldehyde. It is nitrobenzaldehyde is our product, and it is the allylic alcohol, here carbon hydrogen bond, which is oxidized. For here, benzylic carbon hydrogen bond is oxidized. This one and this one is also oxidized. This carbon hydrogen bond is also oxidized, and that is why you will get these type of three products. This is the pyridine which is recovered. So this moiety is converted into formic acid, and then formyl group is attached to it. Now the chromium oxide, when it is added with pyridine, you will get pyridinium dichromate, and that pyridinium chromate is actually responsible for the oxidation. Here OH will attack on the central metal atom chromium. This will be opened, and a chromium oxygen bond is formed like this. And then this will abstract this proton. This electron comes here, and it is resonance stabilized. And then this proton, which is abstracted, and electron pair comes here, and this electron pair comes here, and it will get this proton. So this bond is also broken down. So you will get at the end nitrobenzaldehyde and this type of complex. This is the same mechanism for the Collin oxidation. Similarly, Collin reagent. Collin reagent is the mixture of chromium oxide in pyridine in PCM. When you have stirred this one, this solution, you will get red colored metal pyridine complex. This is a structure of dipyridine chromium oxide, which is actually the Collin reagent. It is an alternative, a very good alternative for PCC and for Jones reagent, and for specialized for acid sensitive group. So this Collin reagent will oxidize secondary alcohol to ketone. How it is prepared? Just take pyridine chromium oxide in DCM at room temperature, stir it, you will get this dipyridine chromium oxide, that is a Collin reagent. What is the synthetic utility of Collin oxidation? The first one, that you can use this strategy to oxidize all those alcohols which have acid sensitive functional group. So that can be saved. And also, number two, you can also oxidize olefins to enones. This is the second synthetic utility. And the third one is that you can oxidize alkynes to acetylenic ketones. Although it is in low yield, but still you can convert this. So synthetically, it is the major synthetic utility is its oxidation of those alcohols in which there is acid sensitive group, because this is the basic medium. So this is the end of Collin oxidation.